Good morning, mathematicians. Um, I hope you didn't think I abandoned you on your weekend. Oh, I just added myself to watch later. Uh, gotta shamelessly like my own stream. What? It didn't let me like my own live stream? How dare it? So maybe we'll get back to yapping about Hecke algebras today. Hello, morphisms. New contender for first in chat has entered the competition. Welcome, welcome. Uh, let's see what's going on. Yeah, so maybe I'll get back to yapping about affine Hecke algebras. If we don't have a bunch of questions, but hopefully we have questions. But let's start. Good morning, Matt Miller. Let's start by looking at what's going on Reddit. Commutative diagrams are amazing. You're absolutely correct. Commutative diagrams are amazing. How to not sound elitist or condescending in mathematical circles. I don't know, man. Just don't be a dick. Oh, I shouldn't say that. I shouldn't say that. I'll get my stream will get shut down. Oh, I'm not allowed. I don't know. Oh, you're slacking quality. Yeah, yeah. You and Edit Smith. Um, yeah. I don't know. I don't know what I'm allowed to say on stream or not, or why. The stream's still going. I don't know. Context, not a mathematician, aerospace engineering PhD student. Okay. Undergrad was in physics. Often struggle to navigate the between semi-pure math and theoretical engineering. More specifically, how to describe my own work and interest of people in engineering and academia without giving them the impression that I look down on more applied work. Then I mean, if you don't at all, then I don't know. Uh, yeah, I don't know why you'd be concerned. Although research in the academic world of engineering is seldom concerned with being too general, theoretical, or rigorous. I mean, that last one is a little concerning. Uh, uh, I mean, yeah, there's a certain definitely. I mean, it can be advantageous, I think, probably to drop some rigor to actually get some work done because, uh, yeah, but no, those words still carry a certain amount of weight, and it seems to have a connotation of being better than. Well, I mean, a more rigorous thing is better than a less rigorous thing. I mean, in any context, it just means you have better assurances. But I don't think that means that pure mathematics is strictly better than applied math. I don't think that's the same as pure math being better than applied math or something. I mean, yeah, sometimes you need a third term. Hi, Edit Smith. Hi, Edit Smith. Sometimes that means you need. Oh, hello, Panzer Kampfwagen. Ugh. 1, 2, 3, 4. Oh my god, my German is terrible now. Not that it was ever good, but it was better. Um, uh, cannot have a connotation of being better than. Yeah. Uh, Yet, that is the nature of my work, and everyone must pitch their work to others. I feel that when I do so, I sound like an arrogant jerk. I don't know. I mean, it's good to be mindful of these things and to not. Hello, astromathics. It's good to be mindful of these things, um, and to actively try to not come off as a jerk. But uh, I mean, I wonder if does this person have any reason to think that people are interpreting them as a jerk? Can we go back to the discussion of what Chern classes are? Sure. You'd like to get the intuition behind what they're measuring. I'm familiar with the basic definitions. Actually, I can't help you too much there, because I wouldn't say that I have an in depth um, knowledge of Chern classes. Uh, oh, what's going on in this document? I wouldn't say that I have, yeah, a super in depth knowledge of uh, turn classes and what exactly they're measuring. I mean, I know this. Oh, let me need to see chat. Hello, Artorius. Hello, hello. Uh, the connection on a vector bundle. How should I write? How do we write it? Like E omega. The connection on a vector bundle somehow allows us to do derivatives, and I mean the curvature is somehow, well, as you can imagine, measuring some kind of curvature. um, I never learned that part of the story properly because I sort of like took this as given, and then I went off and like did things with the curvature that were being used for like other purposes, like when I did this for my master's project, like it was um, a sort of tool that my supervisor and his collaborator were using. They were using the curvature or some sort of like slight augmentation thereof in order to create some particular kind of thing that was then used for other purposes, right? So I kind of just like learned enough to work with these things so that I could go and do that stuff. Um so yeah. um I mean, the so one thing about Chern classes, actually, so here's what I can say. So Chern classes of some vector bundles, right? Like these live in some sort of like homology or cohomology of like your base space. And um generally, as we've talked about on stream before, homology or cohomology can be viewed as some sort of like obstructions or something to being able to solve some sort of differential equations or something. So one thing that you know so if you can find some non-trivial um, Chern class, right? If you can find some Chern class representing some non-trivial element that like creates some obstruction to maybe solving a differential equation. um, One use of Chern classes is also so detecting, say, if a vector bundle is trivial or not. A trivial vector bundle, right? So uh like if I draw a picture maybe of the vector bundle, just the trivial vector bundle of R1 times the circle, right? That's the tangent bundle. Then here's this is the line 0, and you're looking for well, we can always find what's called a zero section in this vector bundle, right? So that is it's just it picks out the zero vector everywhere, right? So the vector bundle, the total space of the vector bundle is R1 cross S1. We just have our ordinary projection map, and a section, of course, is a map going in the opposite direction, where IS is the identity. And so in this case, we can define a section where for each point in the circle, right, this it just picks out the zero vector, and we can see here that this is continuous. And in fact, if I draw another picture here, So again, this is the zero line. Of course, this cylinder extends infinitely far in both directions. Notice that if I have any section, right, and I have any section, let's say it start here, well, as I move continuously around the circle, actually, in this case, as I move continuously around the circle, it's possible for me to find a non-zero section. So this section never vanishes. But now, if I instead were to take the Mobius vector bundle. So the trivial vector bundle, you can always find a non-vanishing section. But if we imagine the Mobius vector bundle, which I don't know a good way. I don't know a good way to draw this on stream. Well, okay, let's look at the flattened out version of the Mobius strip, right? So the flattened out version says that like this line is anti-identified with this line. Well, and of course this is going in infinitely far in either direction, right? So it's not a Mobius strip, but rather like a whole Mobius line of the real numbers. So maybe I should put a dotted line above and below because it sort of goes on forever. But these sides are sort of oppositely identified. And then let's say that this was the zero section. This is everywhere, sort of, the zero line through the Mobius bundle. Then well, let's see what happens. So say we started a point here, and we want a continuous section, right? So we're moving this point here, 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 and now if I go, I'm trying to avoid zero, right? I'm trying to see in our trivial vector bundle, we were able to create a section that is nowhere zero, right? So xx is not equal to the zero vector for all x in S1, right? A non-vanishing section. And so when we hit this line here, this point actually corresponds to this point up here. And so in order for this to be a continuous section, we have to somehow get back to our starting point, and it's simply impossible to do that without crossing the zero somewhere here. And so for the Mobius bundle, we see that there are no sections which don't vanish anywhere, right? There's no non-vanishing sections. And in fact, this corresponds to the fact that the first Chern class of this bundle is non-zero. So one of the things that Chern classes can be used to measure is something like non-vanishing or vanishing sections. And Chern classes can detect these sorts of things, and so it can detect things about like whether the vector, because you might have some complicated definition of a vector bundle, and then the question is, well, is this vector bundle that I found actually trivial or not? Which that could be, that might not be obvious depending on the definition that you've taken, but and here we can draw nice pictures, but like, what if it's a much more complicated base space and total space? Well, if you've got these things, like if you've got Chern classes, then you can turn this into some sort of algebraic computation and determine it that way. That's the extent of what I know about Chern classes, to be honest. Again, I haven't really studied these in depth. Speaking of classes, what exactly is the equivalence class in Chow groups? What does it mean to be rationally equivalent to zero? Is it up to algebraic cycles? Gosh, I feel like I've learned about Chow groups before, and stuff basically went in one ear and out the other. Yeah, yeah. Yeah, I guess, I'm not a good person to ask. I'm not a good person to ask about that. I remember like my supervisor explaining it to me that it's somehow like, I guess stuff you want to do in child groups is like, if you somehow have like two lines intersecting, that maybe you want to like perform some, so they might intersect at a point. Like if you had two lines intersecting at a point like this, now you have a singularity at the intersection, right? So, like, if we imagine this happening like in A2, then the set is basically the equation. It's like the union of the solutions to these equations: x equals 0, y equals 0, right? But now this has a singularity because, of course, the partial derivatives of these equations are just 0. So the origin 0, 0 satisfies these equations and the partials. So this is a singular point at the origin. But you want to take some sort of smooth approximation to this. And in this case, well, now my picture is upside down because we want to imagine these things as like these two lines should be hovering above, but you can basically just take two disjoint copies here and take the projection maps down onto this. And then that is sort of like resolution of singularities. And my understanding is that somehow like singularities somehow like in the Chow group, again, like I said, I'm not the person to ask, so be suspicious of my explanations, but somehow the rational equivalence should like correspond to some sort of like you're embedding this in projective space, and the rational equivalence is like what allows you to lift these things. I think something like this. Um, yeah, but I would not say that I have a good understanding of these things. Maybe we can go collectively look at what does Wikipedia say about the Chow group? What about, yeah, let's just look up rational equivalence. Rational equivalence in Chow group. Okay, let's see what AI says. No, we're not going to look at AI. Go screw yourself. Let's look at Stacks project. Chow homology. Right. X is a variety multiplied by a P1. Yeah, this isn't giving us the intuition though. Love AI, slap for every query now. Yeah, I mean it's actually not so bad in a lot of cases, but I just prefer to if it does provide links to places, then I'll go look at that. But yeah, I am weary of it. Hello, Lico 12, Lico. In algebraic geometry, when it's smooth, they can be interpreted as cohomology groups through Poincare duality. Right. Wait, is that even true in general? I thought there was some. I mean, I thought. Um, isn't that? I mean, the Hodge conjecture like basically a question about when like you know the Chow groups of projective varieties is isomorphic to cohomology? I don't think that was known in general. You have a question. You want to learn about Schubert calculus. Where should I start? You had a very brief introductory course on algebraic geometry. Well, we happen to essentially be speaking about stuff to do with Schubert calculus. Yeah. So, well, I'm not an expert. Definitely, Chow group sounds like friends going for Chinese food. Well, yeah. I mean, that's what better way to spend a Saturday than getting Chinese food and discussing algebraic geometry over dinner? what is it, 32 and all that, something like this. So there's this book. Oh, what? I have the number wrong. Section. Yeah, 3264 and all that. Yeah, this is by Eisenbud and Harris. So this is uh yeah, this is a book that I've actually read parts of before. Um Intersection theory and algebraic geometry. Yeah, 3264. Yeah. 4 digits, that's beyond my storage capacity for information. The thing is, I don't find this to be the nicest book. Well, what? No, 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 no. It's a nice book. I like it, but it's not the most gentle. Like I feel, hello, Arcturus, GD, hello. But I don't feel like this is the most beginner friendly. Oh no, we're never talking about something specific. Actually, I shouldn't say never, but you're always welcome to ask questions. That's what we're here for. Asking random questions and getting distracted. I just find that maybe there's certain things that I would like to be a little more formal. Hello, femoral. Is that how I'd say femoral? Femoral. Femoral. Uh, yeah, there's just certain things in this book that I can call you homology group. Great. Someone emailed me with a submission for your proofs are trash and called me Mr. Functor Man. So you guys can call me Mr. Functor Man. Uh, yeah, I just feel like there's some things that just really rely on like geometric intuition. That was my impression when I read this before. And I didn't like that so much. There was also some terms that I think that are just not defined, like I don't know if they actually did. I mean, okay, maybe it's not an issue because you're supposed to have a stronger background in algebraic geometry before you read this, but there's like uh terms like they use the term like generic, as in like generically true, which I didn't realize, like let x or what is it, like, if something in algebraic geometry, if something's generically true, normally that means that it's like true on an open dense subset, something like that. Big fan of channel. Great. Good to hear. Good to hear. I am going to keep it up. And yeah, Mr. Functorman does sound awesome. I don't think I can change my channel name, but Mr. Functorman would actually probably be more accurate than K theory, since I barely do K theory. You made it to covariant, make it covariant to set, and you can be Mr. Presheaf Man. Yeah. Yeah. Well, then at that point, I mean, why not consider a site and be Mr. Sheaf Man on an arbitrary category with respect to some certain Grothendieck topology. Yo, K theory, just a comment here. Love algebraic geometry, and based on a good difficult metric, it basically carries 90 to 91% of mathematics difficulty. Did you realize that? Uh, does it? I don't know. I mean, abstract, definitely algebraic geometry is pretty abstract, famously abstract and difficult. But yeah, I don't know. There's a lot of very difficult math that has nothing to do with algebraic geometry. Uh, Make it end objects, and you can be Mr. End Stack Man. Yeah. Well, I definitely need to get my head around end objects more. But I read a document recently that I feel like I understand stacks better now. I feel like I just need to do 2 or 3 basic exercises, uh, and then I'll be much happier with stacks. So yeah, the only reason you want to learn Chow groups is because of Chow fun. You can definitely change channel names. You've done it. Oh, interesting. Okay, well, I'm gonna consider that. I might rebrand as Mr. Functor Man. I don't know. I don't know. Yeah, but I already made a new email called K Theory Tutoring, so I don't want to change that again. Based on the metric, it's like 6 sextillion difficulty points relative to the simplest possible math. Yeah, I could believe. In a past office hour, I talked about the affine Hecke algebra. I forgot. Why is it affine? Yeah, so part of it is there's this thing, there's like okay, I'm probably gonna butcher this explanation, but so the finite Hecke algebra. Um this touches a bit on what we talked about last night, so or last time. Uh so very similar to something we talked about last time. One considers instead the algebra. You look at the FP points of your group, and you look at the bi-invariant things with respect to the Borel subgroup. Um, and this is the finite Hecke algebra. And it's basically given by for each element of your Weil group. Um, you have a generator TW, and you're subject to the relations. What is it? So for your simple, like the simple reflections in your Weil group, you have this quadratic relation, and you also have the relation that if the length of UW is the length of U plus the length of W, then you say that TW is TUW. Um, you found the hardest paper of math by accident. Uh, Interesting. Do tell. Do tell. Do I ever talk about some stuff related to the Adels and Idels? You'd be interested in that. I can certainly talk about some of those things. I have, and I will. I think I even have some videos, like the words like Langland's an introduction into them. I talk a bit about the Adels. The theory of dormant operas on pointed stable curves and the proof of Joshi's conjecture. Joshi is in the Joshi who's tried to elucidate the details of Mochizuki stuff. Um, the Adels look promising with arithmetic Langland's group and stuff. Yeah. What is the weirdest favorite metric or topology you've seen on a space in an actual proof or definition? Well, obviously the p-adic metric. Easy. Am I teaching coding? I don't know a lot of coding. Sorry. In fact, I mean, I can do some like basic Python and Sage math and stuff. Oh yeah, the same Joshi. Yeah. Well, I imagine that's difficult. How dare you slander Solstice? How dare you slander topology in chat? How dare you? The good name of topology. Um Anyways, getting back to this finite Hecke algebra. So this is the finite Hecke algebra, right? It's this some sort of it's this. I mean, this basically totally determines it. And I can be a great coder because I'm good at math. Yeah, maybe. I mean, I applied for this. There's this program, this 3-week program in May. So probably video production on my end will grind to a halt because it's like full 8-hour days, but it's like uh, basically to a chance to get like pure math people exposed to some industry projects in case I end up bailing out to industry if no one hires me for a postdoc in the fall. Or I might go anyways because I don't want to be poor. Um, we'll see. But yeah, I need to brush up on my coding skills because you're supposed to be at a certain level of coding, which I'm definitely at, but there's some cobwebs to brush off. Is it okay if you mention me since the attention isn't really that well? Oh, huh? I'm sorry, I'm not sure I understand your question. Uh, okay, a bunch of questions in chat. I'm gonna finish this thing about the affine Hecke algebra though. So this is the finite Hecke algebra. One thing I didn't talk about last time is I mean I want to connect. I still need to tell you how the Iwahori Hecke algebra is realized as an affine Hecke algebra. Um, but it is. And basically, you have these same generators and relations as the finite Hecke algebra, but now you also add in these sort of elements. So this is just some sort of symbol. Don't take the exponential too seriously. Although it is kind of an exponential, but where mu I guess goes over some. Well, you can use either version, characters or co-characters uh, in some root system. So in particular, attached to some group, and so the Weil group part, like these act on like Weil chambers in your root space. So in some 2D or 3D space, you can just imagine it's like translating you to these different places. Meanwhile, this is sort of like think about like affine in terms of affine transformations. Like you have you multiply by some matrix, but then you can also shift, right? So here it's like the Weil group is multiplying by some matrix, is just moving around between some like fundamental domain, and then the affine part, the way that these things, you sort of imagine them acting, is they shift you, they act as shifts. So that's like a um, very loose explanation for why it's called the affine Hecke algebra. Um, what is this? Well, it's just talking about the affine Hecke algebra. It's crazy stuff. Do I follow, read a bit of type theory research? Not really. I mean, I'm interested in it, more specifically homotopy type theory, but I haven't thought about it for a while. And I do have a video on homotopy type theory, though. Um, what do I think about? Have I done model theory? No. What do I think about it? I think I'd like to understand it, but there's only so many hours in the day. Why do I think relatively few people in algebra care about it? I don't. I think largely sociological, just like any branch of math. I mean, it's largely sociological reasons by why some area is more popular than others. I mean, so it is driven, of course, for practical considerations to as well. But yeah, I don't know. I don't know. Any recommendations for getting into algebraic topology with someone with no abstract algebra background? Um, Start with homotopy and advance to homology if you understand enough for more homotopy theory. Yeah, I mean, if you have no background in algebra, I mean, you'll be backfilling as you go, but I like Moncrief's as a first introduction to the fundamental group, just because it has all the topology you need earlier in the book. So you could go read Moncrief's chapter on algebraic topology, which is really just about the fundamental group. Yeah, the problem is if you don't have a lot of algebra background, you need it. But you can also you can just sort of start reading some algebraic topology books. There's the Divisive Hatcher or Tom Eek's book, uh, which I haven't read, but people seem to love, and just backfill as you go. But you will need to do a lot of backfilling. Um, Topology almost made you fail on your candidacy, but it didn't. It didn't. If I do a video on this, you got to name it "What the Hecka." How did you know? How did you know? Wow, I'm so predictable. You really love the office hours stream idea, but you cannot go since. Wait, what do you mean you cannot go? You're here now. You're in GMT plus 3 time zone, and you're only active from 10 a.m. To 12 a.m. Yeah. Well, yeah. I can only stream. Yeah. Sorry. You're here now, though. You made it. So I guess when I stream later, you can make it. Um, who knows? Maybe I'll switch it up at some point to make it more accessible for more people or add more office hours. Actually, that I already spend a lot of time on office hours. That's not going to happen. Well, who knows? What topic is this? It looks really interesting, but you don't have any idea. Yeah, so the stuff above, gosh, I don't even know what to call it. I mean, these are. This is the study of algebraic groups over finite fields. Uh, the other things, this is what I was talking about is Hecke algebras, so finite Hecke algebra and affine Hecke algebra. Uh, yeah, and then, well, I mean, if we're looking at the Iwahori version, I mean, we're getting into representations of p-adic groups. So it's a lot. There's a lot of stuff going on there. You focus on analytic number theory, and then they suddenly ask you about geometry, topology, and even series. Well, I mean, series, you should expect that if you're doing analytic number theory. But yeah, I mean, look, the thing is, I think I think in a candidacy exam, they're gonna push you to your limit, right? They're gonna find where your limit is. So, um, yeah, at some point, like if you answer the questions correctly, they're just gonna push deeper until they find out where your limits are. I think, uh, yeah. You once also proved theorems with exploiting P versus NP and stuff, and that makes use of no axioms possible. I have no idea what you mean by that. Have I ever had a course that I completely never took, but learned as you learned more advanced stuff? This is kind of happening to me with analysis topology. Yeah, I mean, there's a lot of stuff I've never taken a course on, but I've picked up as I've gone. Um, yeah. Well, I mean, it's also hard. How do I draw the like? I've never taken a course on any of this stuff in my research, like Langland's stuff. We have no courses about any of this. Um, so yeah, thanks for the advice. No problem. No problem. Yeah. Well, I'll stream. I don't know. Maybe one of these days, I'll like half the week. I'll make it at a different time or something. Maybe I'll make a poll in my community chat at some point to see what works for people. For you, the time is pretty nice. You come home from uni at 4 p.m., get right into office hours. Nice. Nice. Yeah. Yeah. Thoughts on Chow Fields medalist? Uh, I don't know. He's a Chad. Chow the Chad. Yeah. I don't know. He, well, what can I say? He's a Fields medalist. He's obviously does good stuff. Um, I would also like to better understand some of his work because it does relate to mine. Uh, Never took any math undergrad course, but you learned them by osmosis when you fell into the homotopy type theory rabbit hole. Yeah, I don't think you're alone in that. I think there's a lot of people in the modern internet era. There seems to be a lot of like terminally online people that study homotopy type theory. By the way, when you type some latex stuff, care to write and talk about it with me? You're talking about your research and stuff because you're a 13-year-old researcher. Um, I do offer tutoring. I do offer tutoring. You can email me. you can email me, um, and I'm definitely willing to tutor people. Uh, so I'm happy to talk about with people, talk about anything, everything, and everything in my tutoring sessions. But 13-year-old researcher, uh, well, no, not tutoring. Okay, well, I mean, you can email me. Uh, you can email me. Um, research talk. I would be surprised if you are doing research level mathematics at the age of 13, but I guess send me an email with what you're working on, and maybe we can talk about it. Um, but I only have so many hours in the day. I need to focus on my own research. Um, do I have a Discord? No, I've thought about creating a Discord for this channel, but then I also thought like, oh, if I have a Discord, I probably need to like have then someone to like I need a moderator or something, and like I don't want to be moderating that stuff. Um, but maybe it'd be good. Yeah, I can definitely tutor you in measure theory, definitely like basic measure theory. Um, so send me an email, and we can talk about setting something up. If you send me an email, k theory tutoring at gmail.com. Let me know some of your include in there some of your background, some of the courses you've already taken. Maybe if you're working through a particular course or textbook in measure theory, include some of those details, things you're struggling, uh, wanting to work on. Um, yeah, and we can figure it out from there. Mr. Popular over here. Oh well, that's the plan. That's what I'm trying to do. Be popular. Uh, how's my number theory? I don't know how to answer that. I mean, uh, infinitely better than a random person on the street. As good as a professional number theorist, no. But I've taught courses. I've taken an algebraic number theory course twice. I've Galois theory of primes and basic stuff like that. Definitely rudimentary number theory. I could do no problem. Some I could help with some algebraic number theory, like Galois theory of primes. I do have a homepage. Yeah, if you just search up like Kristaps Baladis Google Sites, I have a page there. Um, yeah. How does one visualize topology before manifolds? I mean, you don't, right? It's funny every time people talk about topology and then they draw a donut or a coffee mug, and I'm like, you're drawing a manifold, not a topological space. But there are freaky ways to visualize crazy stuff, like the p-adic topology. Like if you look up p-adic numbers, like we go to images, like there's these cool ways that we can make visualizations of these crazy spaces. But yeah, I mean, in general, manifolds capture the things that we can uh, visualize easily. Abstract topological spaces are abstract. Since everything just seems like a jumble of axioms at this point. Yeah. Yeah. I mean, basic topological spaces are really, really general. Topological spaces are quite general, and you should not expect that there's a good way to visualize them. I mean, somehow we always lean on our tuition from R2, but uh, you'd mod, but you don't have much time as well. Yeah. And sweet, you guys are going through Evans, property of fine functions. So I don't know much about fine functions. So, but yeah, send me an email and we'll see. The above LaTeX is like a piece of your proof once your hard theorem proving sessions and stuff. I don't think your tech came through and compiled in chat. Do I think topology is learning a waste of time? No, absolutely not. For some reason, it's a mandatory class at your college. Yeah, because like I mean, uh, every math major should learn topology. Uh, it's absolutely essential for like, yeah, pretty much everything. Uh, You should know some general topology. Um, Arbitrary point set topology is basically impossible to get a handle on. Uh, yeah, I mean, there's definitely some freaky topologies out there. Topology is just a subset of the power set with some properties. That's true. That's true. Uh, yeah. Triangulation, Sierpinski space, yeah, and draw one small big circle. Surgery theory is so surreal. Agreed. Actually, I don't know much about surgery theory. Do I think it's possible to give an intro topology course that introduces both point set topology and manifolds? Yeah, I mean, you could definitely try and make it a intro topology course. Yeah, I mean, you could talk about topological manifolds and make a course focused on that. Sure, I don't see why not. Could I possibly draw or write this? Int theta sub x equivalent omega x. Uh, a random thought that crossed your mind. I don't know what the thought is. Those are just, what are those symbols supposed to be? Any tips on understanding the definition of limits as Hom sets in the category of presheaves? I thought I understood them first as universal cones, then as adjoints, but now I'm confused again. The definition of limits as Hom sets in the category of presheaves. Interesting. Is that true? I mean, why would I mean, maybe if your category is concrete or something? Limit limit as Hom in presheaves on C? Yeah, I don't see why that should be true because your limit I'm also confused. I'll have to look into that. As a person who dislikes analysis, topology is a gift. Interesting take. Interesting take. I would not have thought that someone who dislikes analysis would say topology is a gift. My PhD is focused on the Kasdan-Lustig hypothesis, which I've talked about in other live streams, which is part of the local Langlands program. Just read John Lee Intro to Topological Manifolds, gang. Nice. Learning topologies made analysis click for you. Yeah, interesting. That also seems the other way around. Normally, analysis makes topology click for people. Basically, if you take the limit of all tangent sheaves of a scheme, you'd get a differential sheaf or Collar differentials. The limit of all tangent sheaves. I mean, all I know is there. I mean, there's the tangents sheaf of a scheme. I don't know. I don't know what the limit of all tangent sheaves would be. I mean, the yeah. I'm not sure. I'm not sure I understand what you're suggesting. Sounds more like Yoneda embedding than a limit. Yeah, yeah. But there, I mean, there might be some way to combine that with limits. No, there is something. There is some. There is something about that. No, no, no. There is something to that. Where is it? It's somewhere in this book. Um, it's somewhere in this book. Uh, yeah, 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 yeah. A colimit. Well, that's not quite it. There is something here to do though.
Is it this? Yeah, I-shaped diagram in the category. No, that's not it. Well, I think there is a theorem here that is touching upon what's being talked about. Ah, it's this. Yes, yes, yes. Every every pre-sheaf is a co-limit of representables. More precisely, for every pre-sheaf, the tautological map is an isomorphism. I think this is what you're referring to. So yeah, a goat mathematician is Chow the goat Chow is a goat. The goat, I don't know. Papa G is the goat in my opinion, but referring to the first definitions I give on NLab. Yeah, I think lemma. I think in here, I think this is the statement that you're after. Yeah, yeah. Just email me about research level ideas. It will be hard to say in chat. We're going infinity categories. Hell yeah, yeah. One day I'd like to make some videos about infinity categories. Am I going to get into quantitative finance after my doctorate? Maybe, maybe if I want to be really, if I want that sweet money, and I kind of do. Um, yeah, if I could go back in time, I would maybe have gone right into math finance, and then I could have been retired by now and still been streaming. Um, yeah, about math. Oh well. Bonjour, Rodrigo. You wonder what's the latex for that book? It looks cool. Yeah, I've seen these sort of packages before that make lemmas and stuff appear like this. I don't remember where to look. Um, Grothendieck is the goat? Absolutely. Grothendieck is toy. Wow. Wow. Quagsire was raised incorrectly. That's sad. That's sad. Grothendieck was mad at his buddies for taking military funding, so he quit academia and went and lived in the woods in France. Yeah, that's based. World peace champ. Yeah. And it uses Yoneda trickery. Yeah, yeah, yeah. So if you confused me, you're just really loving math at this age, but emailing is slower than spectral sequences. Uh, okay, well, but uh, I'm glad that you're enthusiastic, but if you want to be understood, you've got to take the time to write slowly and carefully. So, how do I feel about studying in Singapore? Uh, I've never studied in Singapore, but hey, if someone gave me a postdoc in Singapore, that would be awesome. Uh, that would be awesome. So definitely open to it. Definitely open to it. Although at that point, would I really be studying? I mean, I guess I'd be studying under my supervisor, but uh, be more a work point in my life, right? It'd be more collaborative work, I would imagine. But it's 10 o'clock. It's 10:01. Been streaming for not quite an hour. John Milner is your favorite mathematician. Nice. Best conference I've been to? Easily the conference in Moraga. You can find a channel. You can find on my channel my interview I did with Wolfgang Zergel. Probably, yeah. That was a really fun interview, but that was awesome. It was just like 2 weeks, small town California. All our meals were taken care of, and it was awesome. And the people, the people there were just fantastic. Is a co-limit just like spitting out n objects from one object, or is it something else? It is something else. And I actually have videos in my What the Sheaf series. I have some videos talking about limits and co-limits. So you can check those out. Came across your first bit of applied algebraic geometry and quant finance this year. Ooh, that Lasserre hierarchy stuff. Ah, that's what it came through. That's what it came from. Nice. Okay, interesting. Good to know. I can do some applied AG in finance. That may be in the future for me. Set theory made you fall in love with math. Awesome. Set theory is cool. Whatever does it for you. But yeah, I'm gonna say goodbye now. So thanks everyone for joining me. This has been a great little chat, and hopefully I'll see y'all very soon.